So, hello everybody. This talk is about operating Korifi for beginners. It's a very brief talk, so it's basically barely scratching the surface of the actual challenge. Here we go. So my name is Julian Fischer. I'm CEO of anynines. We build, run application development platforms for a living. So in this talk, we are looking into the operations of Korifi. Few words about the context. There are many different perspectives you can take on operating Korifi. We are used to operate large Cloud Foundry environments, so our customers are very likely to have multiple Korifi clusters. So eventually, we would like to get to be able to manage a lot of them. So if you just want to run a single one, that's maybe putting different challenges in your way. So first of all, what's the approach on how to automate? So when I talk about operations, I basically talk about operating a thing first for a while and then automate the hell out of whatever people would have to do manually. The first thing you need to understand is what is the life cycle of your component, and what are the things you would be doing on a regular basis. So whenever you run a distributed systems, more or less you do the same things, at least at a certain level of abstraction. So for example, if you look at a Korifi cluster, at some point you need to create one, right? And after its end of life, you will delete it. It's very likely that over the time you'd apply config changes, perform a backup, especially before doing certain lifecycle operations such as version upgrades. In order to do that, you'd also like to have a certain degree of monitoring so that you can ensure that everything is working well. And obviously, making the cluster bigger and smaller depending on the workloads you run on it. So if you take those use cases and look into that, you will see that it makes sense to have a dependency graph first. So it's not about running Korifi. So Korifi has dependencies, and the first thing you'd like to do is be aware of what are the dependencies. So creating a dependency graph may look like this. So it doesn't have to be accurate in this case. It's more like the idea. You approach and look, well, the Helm chart before you can run the Helm chart, you'd have to install the cert manager, for example, and obviously you need a Kubernetes cluster. So you need to be aware of the dependencies of your application. If you're later looking into managing versions, for example, you want to be able to update your Korifi cluster, you also need to version those dependencies, because introducing a new version of the main workload here, Korifi, may require a certain version of cert manager. So at some point you may have to upgrade the dependencies first before you can go to your actual workload. So if you think about those use cases like creating an instance and upgrading it, there's a certain inherent order in which those use cases may appear to you. There's obviously also, from common sense, the necessity to approach automation in an iterative way. I compare it to drawing a fractal. So whenever you touch a certain use case, for example, creating a cluster, you're not starting to implement that feature in its entire depth, but instead you'd use, say, give me a cluster with only a few configuration options in the first approach, and then maybe go to the backup and restore story so that you have a foundation to proceed with other use cases. So in this case, we're going to have a look into creating a new Kubernetes cluster from scratch and creating, for example, a Korifi backup. Because without a backup, you would surely not feel uncomfortable doing something like a version upgrade, which is, if the Korifi cluster is operated over an extended period of time, unavoidable. So this is where things fall into a natural order, but scoping the implementation of each of those lifecycle management tasks is crucial. So what exactly do you need from a backup, for example? So in Korifi, we'll see that this boils down to something that's relatively simple, but in other scenarios this could be more tricky. For example, in a database you'd be looking into different ways of doing a backup, a dump versus, for example, streaming-based backup. And you'd have to ask yourself, well, do I start with a simple implementation and add depth later that provides better functionality? So yeah, how to manage Korifi? There's an I missing. The discussions we had internally, for example, was, are we going to use Helm, which, somehow helps to, get the installation and the upgrade done in a homogeneous way with a fairly simple tooling. And on the other hand, whenever you need to have a quick change in configuration, you have to go through the Helm chart, and it's very likely that you have to touch the Helm chart if you are adapting this to the requirements of a particular customer. So depending on what your particular goal is, you'd have to make the same decision. So use the Helm chart as it is, being ready to contribute to the Helm chart and making pull requests, or go with YAML all the way, which is, I don't know, kind of a painful decision you have to make with Kubernetes workloads all over the place. And Helm is not the only tool to do lifecycle management, so there could be other options as well. So as a rule of thumb, we used to say, well, Helm is simple but less flexible, or at least you have to go through the Helm chart, which can be sometimes a bit limiting, but with YAML you have, more flexibility, but sometimes it's less convenient. So, in the end, if you use Helm, it all boils down to a complicated installation, command like this, where you have to set the appropriate environment variables. In this case, we are using not the most recent version of Korifi, because at some other point, you also want to, run an upgrade. So with Helm, this is pretty simple and straightforward. However, how comfortable do you feel executing an upgrade without having a proper backup? So at least from my experience, the Cloud Foundry environments we run, there are often thousands of applications running in there. Customers would be rather unhappy if we break Cloud Foundry entirely and wouldn't be able to get it back up and running within a reasonable amount of time. So once you think about an upgrade, you also have to think about upgrading the dependencies, which boils down to the same question: how do you lifecycle manage the dependencies? A best practice here would be to, look up the dependency, look up the documentation, and see what's the preferred method that ships with each release of that dependency. So this could be, a very well-grounded description on how to use YAML, which is a lot of components do. Then there could be a Helm chart, or there could be something else, right? So if you have a very, let's say, opinionated approach to operating your Kubernetes workloads, you may also be forced into a very different option. But as I mentioned earlier, you're having that dependency tree, having versioned dependencies, that can become rather hard over time if you don't take care of that early on. So now we don't have so much time, so if you look into how to make a backup for Korifi, it boils down to making a backup of a Kubernetes cluster, because Korifi uses custom resource definitions, and custom resources are stored as objects in the etcd. And if you think about making backups of a Kubernetes cluster, you'd be looking into something like Valero, for example, which allows you to create, well, first of all, there's a Helm chart, which is nice because it's similar to, Korifi itself. And it allows you to create a backup schedule, something like this. So you can take care of the state of Korifi by taking care of the state of the Kubernetes cluster itself. It allows you to create manual backups as well. So for example, before performing an upgrade, it's wise to have a backup of the system you're touching. So in this case, that would be that. Now, restoring a backup is also straightforward. So this is, for example, how we proceed looking into automating a piece of software. So we take a use case from the list of possible use cases. We try to find out the natural order on which to implement which use case. Then we scope the use case. For example, here we want to have a schedule. We also want to have the ability to run a manual upgrade. We put it in the runbook for manual operations. To do that before going into a version upgrade, we'd implement the first version upgrade, and then try to simulate that life cycle so that we have the operational experience from running such a cluster manually before we then take this, what we call operational model, and put it into, the backlog for the people who automate this with whatever tooling we choose to do so. So this is just, one of the use cases that you want to implement, but it shows the general approach to this. It's basically manual operations first. You identify your use cases, you pick the use cases, you scope the use case for the very first minimum implementation you want. You execute those use cases manually, document how you do that, what your experiences are, and if everything works as expected, you can, then put it into the backlog for automation. So our summary is, running Korifi isn't that hard. It's a fairly interesting implementation. The state is getting closer to being ready for productive use. We're very looking forward to invest more time into automating the hell out of Korifi ourselves, and hopefully you've picked up some ideas on how to make your own automation and operations for Korifi today. So thank you very much. If there are questions or anything, I'm around here the rest of the day. Feel free to ask them right away or later. Thank you very much.